Hello, welcome back. My name is Dr. Kingsley. We are still on chemical equilibrium. I've had previous videos on chemical equilibrium. Now, today, I want to, teach us the conditions for equilibrium. What are the conditions that must be established before we can say that a chemical reaction is in equilibrium? Now, I will give you few of them in this class. Now, for we to say that a reaction is in equilibrium, number one, the equilibrium constant of that reaction must be 1. Any reaction that is in equilibrium, we have the equilibrium constant of that reaction to be unity. Unity is simply 1. Then number 2, for a reaction to be in a chemical equilibrium, the rate for forward reaction must be equal to the rate for the backward reaction. That is number 2. Rate for forward reaction must be equal to the rate for backward reaction before you can say that a chemical reaction is in equilibrium. Number 3, the change in Gibbs free energy of that reaction must be 0. Any reaction that is in equilibrium must have its change in Gibbs free energy to be equal to 0. Number 4, the change in enthalpy of the reaction, change in enthalpy, must be equal to the absolute temperature multiplied by change in entropy of the reaction. The change in enthalpy of the reaction must be equal to absolute temperature multiplied by the change in entropy of that reaction. Now, if these 4 conditions are established, we can say that a chemical reaction is in equilibrium. Now, next in this class, we will take facts about equilibrium constant K. Facts about equilibrium constant K. What I mean by fact about equilibrium constant K is what and what do we need to know about equilibrium constant of a reaction. Hello? Now, let us take them one by one. One thing we know about equilibrium constant is if equilibrium constant of a reaction is equals to 1, we know that what? The reaction is in equilibrium. The reaction is in equilibrium. If equilibrium constant of a reaction is 1, the reaction is in equilibrium. Number 2, if equilibrium constant of a reaction K is greater than 1, the forward reaction is favored. It simply means that forward reaction is favored. What does it mean that the forward reaction is favored? It simply means that the reaction will proceed far to the right. Then number 3, if the equilibrium constant of a reaction K is less than 1, what does it mean? It simply means that the backward reaction is favored. If K is less than 1, the backward reaction is favored and the reaction will proceed far to the left. Then number 4 thing, you need to know that the equilibrium constant K of the forward reaction is the reciprocal of the equilibrium constant of the backward reaction. What did I say? The equilibrium constant of the forward reaction is always equal to the inverse or the reciprocal of the equilibrium constant of the backward reaction. If I cross multiply, you can see that what? That equilibrium constant of the forward multiplied by equilibrium constant of the backward will give us what? 1. What it simply means is the equilibrium constant of the forward reaction is the inverse or the reciprocal of the equilibrium constant of the backward reaction. Also, in other way round, the product of the equilibrium constant of the forward reaction to that of the backward reaction is equals to 1. So that is another thing we can learn concerning equilibrium constants. Then number 5, we need to also understand, number 5, that equilibrium constant of a reaction can only be affected by temperature. Only temperature affects equilibrium constant. What does it mean? Equilibrium constant is not affected by pressure, it's not affected by concentration, it's not affected by catalyst, it's only affected by temperature. Now number 6, if a chemical reaction is in equilibrium and that chemical reaction is multiplied by a factor to get another chemical reaction, the equilibrium constant of the new reaction will be equals to the equilibrium constant of the initial reaction raised to the power of the factor that we have multiplied. Now, if we have a reaction A to produce a B, and the equilibrium constant of this reaction is K1. Let me use K1 because this is the first reaction. A reaction that is in equilibrium, A to produce B, have its equilibrium constant to be K1. You can be asked to find the equilibrium constant of 2A to give us 2B. Call it K2. Somebody can ask you what is what? K2. Now, if you look at this reaction which is 1 and this reaction which is 2, you agree with me that what? This reaction 2 is obtained from reaction what? 1. How? By multiplying reaction 1 by 2, I will get reaction 2. And we are saying that K1 now, which is the K2, the new equilibrium constant K2 that we are looking for, will be the initial equilibrium constant of the first reaction, which is K1. Then raised to the power of the factor you have multiplied by. Which factor did we multiply by? We multiply by the factor of 2. It will be K1 raised to power 2. What it simply means is this. Anytime a chemical reaction in equilibrium is multiplied by a factor, the new equilibrium constant will be equal to the original equilibrium constant raised to the power of the factor that we have multiplied by. Now, we can prove this. It is provable. Now, let me say, for example, if you want to write equilibrium constant for this reaction, it will be K1 is equals to product, okay, B divided by the reactant, which is what? A. Then if we want to write the equilibrium constant for the second reaction, that is K2, it will be K2 is equals to concentration of B raised to power 2 over concentration of A raised to power what? 2. What does it mean? It simply means that K2 is actually equals to concentration of B over concentration of A, all raised to power what? 2. All raised to power 2. Now, if K2 is equal to concentration of B over concentration of A, all raised to power 2, you agree with me that concentration of A divided by concentration of concentration of B divided by concentration of A is actually our what? Our K1. So we can replace concentration of B over concentration of A with K1. So that means that K2 will be equals to K1 all raised to power what? All raised to power 2. You can now see that this holds. Now, the final thing I want to give you about equilibrium constant expression is that anytime a reaction or anytime two reactions are added up to produce the third reaction, two reactions in equilibrium are added up to produce the third reaction, the equilibrium constant of the third reaction will be the product of the equilibrium constant of the two reactions that were added up to produce it. Now, what I mean is this. Please, what I mean is this. Quickly, let's say we have A to give us what? B, and the equilibrium constant is K1. Then we have another reaction, C, to give us D, and the equilibrium constant is K2. And somebody asks you, find the equilibrium constant of A plus C to give us B plus D, assuming the equilibrium constant is K3. Somebody can ask you, find K3. Now, what I mean is this. First chemical system equilibrium, A produces B, is K1, and C produces D, is what? K2. And they now ask you to find the equilibrium constant of A plus C to give B plus D. If you look at this chemical reaction, you actually know that it is obtained by adding these two reactions. This is 1 and this is what? 2. It is 1 and 2 that we added up to produce what? The third one, which is 3. That is A plus C to give what? B plus what? Plus D. What will now be the equilibrium constant? K3. We are saying that the equilibrium constant K3 will be equal to the product of K1 and what? And K2. Because it is K1 and K2 that were added up to produce what? The K3. So that is why it is the way it is. It can also be proven, like we proved the other one. Now, I want to stop here for today. We can continue another day. Thank you for always following up this video. Always help me to subscribe, share this video, like this video. Thank you very much. You can always comment in the comment section.